Keep in mind the rule 4 to describe authentic situations. You can use an equation, a graph, a table, or words to describe authentic situations, similar to describing equations or expressions. We perform a unit analysis of a model's equation by determining the unit of the expressions on both sides of the equation. The units of the expression should be the same for both sides of the equation. Let's try out an example. In this case, our example, the average gas mileage of a specific vehicle is 30 miles per gallon. Let G be the number of gallons used to drive the miles. So, just to get a little bit ahead of the game, let's write the next question here. A. Complete the table to help find an equation that describes the relation between D and G. Show the arithmetic to help you see the pattern, or a pattern. In this case, here's the table. Just brought it over and copy it to make it a little bit bigger. Now the question is, we know the rate that the car is driven. It's at 30 miles per gallon. Are we using that 30 to subtract? Let's say if we go 30 minus 30, that would give us 0. That wouldn't work. Are we using it to add then? 30 plus 30 would give us 60. That wouldn't make sense. If you're driving a distance of 30 miles, you'd get 60 gallons consumed. Nope, wouldn't make sense. So in that case, have a multiplication. 3 times 3 gives us 9. Add the 2 zeros, makes it 900. You'd consume 900 gallons in 30 miles. Oof, you must have a huge vehicle. Well, how about division? 30 divided by 30 gives us 1. Hey, that might work. It looks like we get 1 gallon consumed when you drive for 30 miles. Okay, how about if we drive for 60 miles? 60 divided by 30 gives us 2. Hey, that works. We get 2 gallons used up after driving 60 miles. 90 divided by 30 gives us, therefore, 3 gallons consumed. 120 divided by 30 gives us 4 gallons consumed. So in general, the distance divided by 30 will give us the amount of gallons consumed. So there's our equation in this case. We figured out our equation. Do keep in mind, sometimes we don't have to make it too hard to make an equation. Sometimes it's just a visual observation that we can do, or a quick check that we can do to be able to find the equation that we can use. Okay, so now that we found the equation, D divided by 30 equals G. Let's continue on to the next one. Once again, do remember the table that we had before. It's not critical, but the equation is the critical one. We found that D divided by 30 equals G. Distance divided by 30 miles per gallon gives you the gallons. Now the question is, B, perform a unit analysis of the equation found. So we want to perform a unit analysis. Let's realize that the D are representing miles. D represents the miles driven. And G represents the gallons. Okay, G represents the gallons used up. Okay, 30. 30 has units of miles per gallon. That's what was stated in the intro of the example. 30 represents miles per gallon. So let's substitute in for D, 30, and G. So D represents miles. 30 represents miles per gallon. Therefore, we're going miles divided by miles per gallon equals gallons. So there is our unit representation so far. That's what each one of those variables or constants represents as units. And now do notice, it makes it kind of hard to visualize miles divided by miles per gallon, agreed? Even if I try dividing them, writing as a fraction sign, it would make this pretty rough. So do notice, gallons on the other side, pretty straightforward, but miles, if we write as a fraction format, divided by miles per gallon, this becomes really tricky to see, or at least to visualize. Well, a while ago, I came up with this idea or concept, well, just way of thinking, when one of my friends had a hard time seeing these types of problems, how to simplify this form of the problems. You have fractions over fractions. So, in this case, my idea was to draw a monkey hanging from a tree. So there's a monkey hanging from a tree example. Notice that the miles represents the bottom of the monkey hanging from that tree. The tree branch is the fraction sign, the big one. And the gallons represents the head of the monkey. which is hanging from the tree once again. What happens as this monkey swings up? Notice, miles is the body of the monkey or the bottom of the monkey, and gallons is the head of the monkey. What happens when this monkey swings up? Notice that you have the initial miles unit stays up at the top, agreed? So the initial miles unit is at the top. When this monkey swings up, the bottom, or in other words, the miles stay down. But the head of the monkey go up. The gallons go up to the top of our fraction. So now it becomes gallons over miles instead. In other words, it's reciprocal, right? Remember the reciprocal. Same concept. So therefore we get on the other side still gallons. Does this make it easier for you to visualize? If it does, I recommend you use it. If it doesn't, forget I ever mentioned it. So notice now that we have miles on the top, miles on the bottom. This makes it easier because we can cancel the miles. Miles are gone. That leaves us just gallons. So that means gallons equals gallons. Is this a true statement? Yeah, it's a true statement. So there we go. This is our unit analysis. And it's correct. We've noticed that we end up with gallons on both sides of our equation. C, graph the equation by hand. Well, I've kind of gone ahead and we won't be quite graphing it by hand, but rather I made already a quick sketch. So there is our sketch. And the question now is, how many gallons are used to travel 75 miles? Do notice on the left side I chose gallons. On the bottom side I used D miles, and I put a label at the top, or description, or a title, right? Gas consumption. So on the left side, gallons, I have increments of ones starting from 0, 1, 2, 3, 4, etc. On the bottom, I have increments of 50, 50, 100, 150, etc. But in between lines, I have tens. So we 10, 20, 30, 40, then you get to the main line, 50, 60, 70, 80, 90, and main line, 100, etc. So in this case, we're looking for 75 miles. When we drive 75 miles, let's see right there. When we drive approximately 75 miles, that's between those two lines, right? So after the 50, you'll see 60, 70, between the 70 and the 80th line. Agreed? And we move right up until we meet our graph, in this case, our linear regression line. And we go back to the left, and that will give us an estimate of the gallons used. It's roughly at 2.5, right? So between 2.4 and 2.6, roughly somewhere between there would be good. In this case, my guess is 2.5 gallons consumed. So to drive 75 miles, we would roughly use 2.5 gallons. And keep in mind, in many cases, we can estimate or answer questions using just our graph.